We're good? Problem 4 is an example of what are called roots of multiplicity. Multiplicity. And this goes, Matthew, to your point about just touching the graph. So roots of multiplicity. So let me write the equation. So number 4 is y equals 2x squared times x plus 1 times 3x minus 4 times x minus 2 cubed. And again, same directions. Sketch, roots, and behavior. So again, I'm going to do step 1 is like, let's find the roots. So I'm going to split. So 0 equals 2x squared, 0 equals x plus 1, 0 equals 3x minus 4, 0 equals x minus 2 cubed. And now this is the key step here. The difference between a problem like this and problem that we had before is the following. We didn't have this like cubed out here. This is new. We didn't have one term, call this a term, or one factor that was raised to a power bigger than 1. We never had one factor raised to a power bigger than 1. This is something new. We call this a triple root. Because there are essentially like 3 roots within 1. Was this discussed last year?
Yeah.
A little bit?
A little bit.
Okay. You'll kind of remember it? Okay. We call this a triple root. So we solve it the same way. We take the cube root of both sides. We say 0 equals x minus 2. We add 2 to both sides. And we have x equals 2. That's the root. But this is a triple root. Give me 2 more minutes. This will make a lot of sense. Let me solve this one. I'm going to add 4 to both sides. 4 equals 3x. I'm going to divide both sides by 3. 4/3 equals x. Let me subtract 1 on both sides. X equals -1. We divide both sides by 2. 0 equals x squared. Again, notice something. We have a factor raised to a power. The difference between this and this is that here was x squared equals 1. So when you take the square root of 1, you get 2 numbers, plus or minus 1. Here, when you take the square root of 0, you only get 1 number, x equals 0. Notice the difference. When I said x squared equals 1, x equals plus or minus 1. When I said x squared equals 0, x only equals 0. There is no negative 0. It's just 0. So we have a double root at 0. These are both single roots. This is the standard is a single root. Single root. This is a double root. Why? We expected 2 roots. In this case, we got the 2, plus or minus 1. In this case, there is only 0. There is no negative 0, hence the double root. Here we were expecting 3 answers. We only got 1, hence the triple root. The easy way to think about it is if you have a factor raised to an exponent, it is that exponent root. So triple root, double root, single roots. Michelle. Yeah. So let's now see what the graph looks like. So if, you're going to want to write this down, if the multiplicity of the root is even, what we mean by that is a double root, 4th, 6th, any even number root, the graph just touches or just bounces or just kisses the axis. Graph touches, and I'll show you what the picture looks like in 1 second. Bounces, kisses the axis. If the multiplicity of the root is odd, single, triple, fifth, etc., the graph goes through the axis. 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 And if you give me 2 minutes, I will show what this looks like. Let's take 2 minutes then. So before we actually graph this, I know there's a root at 0. I know there's a root at -1. I know there's a root at 4/3, which is 1.3 repeating. I know there's a root at 2. I want to find out, though, before I graph it, the degree and the leading coefficient. So the degree... Any thoughts on the degree? Or I reveal it? What's the degree here, Matthew?
It's going to be positive.
Degree. That's a number, right? What's the degree? Remember, the degree is the highest exponent. Lucio?
Hold on. It's gonna be 7.
7. Why 7?
Because once you multiply the cube by x minus 2, it'll be x cubed
Right.
minus 8. 3 times 3x would be like 3x to the 4th.
Right. Exactly. So x cubed plus another x is x to the 4th, plus another x is x to the 5th, plus 2 more is x to the 7th. Remember, if the bases are the same and you multiply, we add exponents. So it's degree 7, so it's odd. The leading coefficient, 2 times 1 is 2, 2 times 3 is 6, 6 times 1 is still 6. So it's positive degree, so I'm going to start, it's positive leading coefficient, so I start up here, I come down to the 2, it's a triple root, I go through it. Come up to the 4/3, single root, go through it. Come down to 0, double root, so I just touch it, come back up, come down to -1, single root, go through it. Again, we have no idea how tall or short the humps are. We're just sketching. And I would write as x goes to infinity, y goes to infinity, and as x goes to -infinity, y goes to -infinity. Questions? Daniel.
Well, it's not for this, but like, is there any other case where like it's the square is like, or cube is negative?
I'm not sure what that means.
Like in the equation right here for let's say 1, it's 2x -2. Like,
2x to the -2 power?
yeah.
No, we would not give that yet, because we haven't talked about how to divide polynomials, so no. Good question. Michelle. We can stop the video soon.